This is the last talk of the day, so now we are going to see who is stronger, me or the audience. I hope at least me, I am going to, I say, to be here and to finish the presentation. Okay, so I'm going to present the ontology of visual objects. What we understand by visual objects. The visual object is an object which can be depicted as images. And in other words, it's an object which can be seen by humans. Why we have to develop such an ontology? We actually had a project aiming at the creation of a large data set with images and objects annotated within images. The annotation of objects was directed in bounding objects and also in labeling objects. And during our work, we found out that other available data sets with annotated images actually are organized in very shallow ontologies if some ontologies were used. So we actually decided to develop such an ontology and to use it in describing the objects between images. The ontology actually was based on WordNet. Why? Because our Department of Computational Linguistics actually is developing Bulgarian WordNet, and the Bulgarian WordNet is approximately of the same size as the English WordNet. So we have this large semantic resource at our disposal. WordNet also can be viewed as an ontology if we consider only if only is a relation, and if we are ready to discard some discrepancies which are still encountered in the WordNet. So our ontology benefits from WordNet, providing ontological representation of visual objects based on WordNet concepts and hierarchy. For example, the following concepts are present in WordNet. For example, chessman, chessboard, chess player, also skate and leotard. But also there are many objects which have to be described but are not present in the WordNet. Actually, in our ontology, which at the end resulted in approximately 900 labels, 900 concepts. Half of the concepts are present in WordNet and half of them are not. In other words, the ontology extends WordNet by adding new concepts corresponding to concrete objects and formulating new relations that express the object's function, purpose, and location. An example of such an object, new concept, is the concept denoting the object figure skater. And here, all the relations which are exemplified are newly introduced relations because in WordNet there is a uses and used by relation, but it relates noun synsets and verb synsets. Here, it's obvious that objects can be described only by nouns. So this is a new relation between nouns which are related with concepts which can be depicted in images. Our data set called multilingual image corpus is a large data set because it contains almost more than 21,000 images and more than 200,000 object annotations within them. And it's organized around 4 thematic domains. Those are the domains of sport, transport, arts, and security. And these four thematic domains are further subdivided in 130 subdomains. We collected images from different sources which provided copyright-free images, because comparing to other existing datasets, we wanted to provide the datasets which can be used without any copyright limitations. At the beginning, we collected over 750,000 of images, which further were reduced to the amount which I already mentioned. One of the reasons to reduce the number of images was actually not only the quality of the images, but also the definition of the ontology of visual objects. The task for the annotators was to outline polygons or the boundaries for the individual objects and the images. And for example, in the second picture, you can see a boat which is already automatically annotated. And in the third picture, it's a boat which is manually corrected and also labeled with the correct label for the concept it is represented. So the task for the annotators was to outline polygons of individual objects within images and to classify the objects again the classes from the predefined ontology. Actually, because we had a very limited span of time, and our aims were quite changed, we decided to develop a pipeline for automatic preprocessing and automatic labeling of images and automatic also outlining image boundaries. For this purpose, we use available frameworks as log, detectron tool, and fast RCNN models. And we trained them on the COCO dataset, which were used for the generation of the annotation suggestions. After this stage of our work, the annotators actually corrected, if necessary, the automatic predictions of both boundaries and labels. And in many cases, for which there wasn't classes in the COCO dataset, the new boundaries have to be drawn and the new labels have to be chosen. I would like to mention one more time that our ontology consists of over 800 classes, comparing to COCO ontology, which contains exactly 81 classes. This is the image, multi-level image corpus in numbers. So I already mentioned that it's big enough in their size, although nowadays we know that we need larger and larger data sets. What were the criteria for the establishment of classes in the ontology of visual objects? We have to decide between the levels of specificity and generality of the concepts. And we input in the ontology only specific concepts at a certain level of granularity, which is more concrete compared to classes that are usually used in image datasets. For example, in the datasets like COCO dataset, which is very famous actually, the concept which used is car. We use many different concepts to classify different kind of cars as limousine and sedan, but we didn't go deeper in the classification because, for example, we didn't classify cars or limousines, whether they are Chrysler or other Mercedes or BMW and so on. Because we should decide the level for the annotators at which they have to easily to decide and easily to classify particular objects. The other criteria is the high frequency of occurrence. Actually, this criteria was based on the collection of images which we gather. And for example, I'll give you an example. At the beginning, the such concept as baby rata was selected to be included in the data set. But it was discarded from the, not from the data set in the ontology, but it was discarded from the ontology because there wasn't so many images to which such object was depicted. Other criteria is coverage in ontologies. So we actually tried to insert in our ontologies or concepts which are already encoded in WordNet and through WordNet in other ontologies because we wanted to benefit from the knowledge which was already formalized. And the last criteria was covering gaps in existing ontologies. It was noticed that different concepts are not included in WordNet. I gave you the example with figure skater, but also many other concepts actually which are regularly used are not by one or the other reason are not included in WordNet. Our ontology consists of classes, relations, and axioms, as most of the ontologies. What is different for our ontology is that classes are divided in dominant classes, attributes, and parents. For example, player is a parent class to volleyball player, and contestant is a parent class to player, and so on. Let me speak with more detail about the different type of concepts. We call dominant classes these classes that actually, or these classes that actually relate with the main players within a particular domain. For example, in the domain of sport, dominant classes are such concepts as figure skater, chess player, pole vaulter, and so on. On the other hand, as I mentioned, this as we call them dominant classes, are not encountered in WordNet for each particular concept we would like to include in the ontology. At the end, actually 277 classes were selected. And here I would like to say that we started with 10 different domains. And at the end, we resulted in 4 domains subdivided, as I mentioned, in 113 domains, subdomains. For each dominant class, a parent class is related via the easy relation. Here, the WordNet hierarchies again help. And for example, we include such parent classes which can be described as visual objects. For example, we include in ontology contestant and human, but the next level in WordNet, which is living being, is not included in ontology because it cannot be described as visual object. Attributes is something which is a bit particular. It's not ontology, or it's not usually used in ontologies because in our understanding, attributes are such classes which show different functions, different roles, different instruments. The main players, the dominant classes actually use in the skins which were depicted at the images. For example, skate and leotard are attribute classes to figure skater, and chessman and chessboard are attribute classes to chess player. We introduced more relations than the relations we have in WordNet. Only is a relation is inherited from WordNet, and the relation has part also, which is a mnemonic relation, is also inherited from WordNet. These two relations are hierarchical relations, and their features is that they are reverse and also transitive relations. To the meronymic homonymy relation, it can be transitive if such actually relations can be viewed at the world in which we live. But in usual case, only hypernym relations are transitive relations. Other relations which are introduced additionally in the ontology are non-hierarchical relations, and these relations describe the links between the dominant classes and their attributes. For example, something could be part of something else, or something could be an instrument with which a player can play with, and so on. These non-hierarchical relations are relations between dominant classes, as I mentioned, and their attribute classes. They are symmetric, irreflexive, and non-transitive relations. It's an example of symmetric, irreflexive, and non-transitive relation is the relation is next to. We also formulated some axioms. Axioms are statements which were developed on the basis of the features of the relations, for example, and which are always true. For example, if x is on y, then y is around x. If x is next to y, then y is next to x, and so on. Altogether, 15 axioms were introduced in the ontology. Actually, for the format we use labels to name the concepts, and in usual case, if the concept is represented in WordNet, we use one of the synonyms at the respective synonym sets at WordNet. If not, we have to decide between the possible candidates and to pick such that adequately refer to the concept. The ontology is presented in a JSON format. Also, in the scope of the project, classes were developed in 25 were translated in 25 languages. Not only classes, but also their synonyms and definitions by means of openly available WordNets, if not present there by BabelNet, or if not present at BabelNet by machine translation. We evaluated the ontology during the annotation, whether a class is a visual object or not, whether all depict objects in a selected image can be described within the ontology classes, and whether new classes can be added if necessary. Our main contributions are that we defined the ontology of visual objects whose classes are sufficient to annotate objects in 130 thematic subdomains. We introduced also attribute classes, and we defined the relations between dominant class and attribute classes that are related with it. Benefits from using the ontologies are as follows, particularly our ontology: selection of mutually exclusive classes, built-in interconnectivity of classes by means of formal relations, easy extension of the proposed ontology with more concepts corresponding to visual objects, and of course many others. Also, the ontology provides options for extracting relationships between untagged objects, between diverse data sets with different levels of granularity of object classes, or between appropriate sets of images illustrating different thematic domains. All of the outcomes of our project, the data set, which consists of images, resized images, image metadata, annotations, ontology classes, and multilingual descriptions of classes, is available under the Creative Commons Attributions Share Alike 4.0, and then are downloadable by many different repositories. So all of this is available. And at the end, I'd like to thank the project. Actually, in the scope of it, we managed to develop this work. It was financed by the European Language Grid. Thank you very much for your attention.